everyone, this is Dr. Esperanza and welcome to our math workshop. And for today we're going to be working on integers, also known as the positive and the negative numbers. And if you think that you're struggling with your algebra classes, geometry classes, or maybe even trigonometry classes, most likely you haven't mastered your integers yet. So for today, we're going to be working on this lesson, and do stick around so you'll be able to master the fundamentals needed in succeeding in your math classes. For today, we're going to be working on integers and how to work out problems involving positive and negative numbers, because in mathematics, fundamental is everything. And when we say fundamentals, it all boils down on your mastery and your understanding on how to use your multiplication table. And for today, we're going to be using the multiplication table, or it is required for you to understand the lesson of algebra, trigonometry, basic math when you're working with the multiplication table. And that's what we're going to be doing. And for today, we're going to start with our work on integers. And integers are pretty basic for most students, but if you think that you're struggling on adding and subtracting your positive and the negative numbers, it all boils down on your understanding about the number line. And the number line is the visual on how you could visualize how to add and subtract the positive and the negative numbers. Just like when we are multiplying, we're not going to be able to answer a basic multiplication problem like 5 times 3 or 7 times 8 or 6 times 4 if you don't know your multiplication table. And it's the same thing as adding and subtracting positive and negative numbers. You should know your number line so you'd be able to understand how to add and subtract positive and negative numbers. And for this problem, 1, 2, and 3, I'm pretty sure most of you are able to answer this without the use of the number line. But for the sake of you who have not seen a number line or don't know how to use the number line is pretty simple. If we're going to be adding 5 plus 3, the first number that you're seeing, which is 5, it means that you're going to be starting with that positive integer, also known as positive whole number, and then this addition sign of plus 3, it means you're going to move 3 units going to the positive direction or to the right. And if it's minus, it means negative. That means you're going to be skipping your number of units to the left. But since this is 5 plus 3 is simply 1, 2, and 3. And that is why the answer here is equal to 8. And it's pretty intuitive because as individuals who are working on an algebra problem, we've seen regular math problems like this already. So doing 5 plus 3 and 5 minus 3 could be pretty simple. But if we're going to be using the number line, 5 minus 3, we will start at 5. And since it is now negative 3, it means the direction of our skips will be to the negative side. So we're going to be skipping 1, 2, 3 units, and that's why the answer is 2. So that is how we use the number line when we add and subtract positive and negative numbers, also known as the integers. So if we have 7 minus 5 means we're going to start with 7, and we're going to be skipping 1, 2, 3, 4, 5 units, which is also equal to 2. And by doing so, you'll be able to answer bigger problems that's no longer in the number line, because the number line is not limited to only negative 10 and positive 10. So if we're working with 25 plus 12, it goes to show that at 25, you'll start at 25, you will move 12 units to the positive direction, and that will be the answer to the problem that you are working on. So for number 1, we have 8, we have 2, and we have 2 using the number line. And for 4, 5, 6, knowing what you know now with your number line, 25 plus 12 is equal to 37, 19 minus 9 is equal to 10, and 75 minus 20 is equal to 55. And that is how we use the number line when we add and subtract integers. Now, to make it a little bit more challenging, now we're working on numbers with positive and a negative sign. And for most students, especially students in my algebra class, or sometimes even my statistics in calculus class, they're struggling on how they work out problems involving the positive and the negative value. But if you're going to be looking at it using the number line, it's fairly simple. So the instruction is negative 5 plus 3, it means you're going to be starting at negative 5, and negative 5 is on this side of the number line, and you're going to be adding 3 from negative 5. So that means you're going to be moving 3 units to the positive direction starting at negative 5. So you'll have 1, 2, 3, and the answer is negative 2. So in mathematics, try not to guess what the answer should be, or try not to come up with rules in your head, but just work on the number line so that you will have a better understanding on how integers or positive and negative numbers work. So this one is negative 2, and if we're going to be working with 5 minus 8, 5 minus 8, you start at 5, and you go 8 units to the left, 1, 2, 3, 4, 5, 6, 7, 8. That's why the answer is negative 3. And if we're going to be working with negative 7 plus 10, it means we're going to start at negative 7, and we're going to be moving 10 units going to the positive direction. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer is positive 3. So that is how we use the number line if we need to visualize how we're getting these integers as a result of adding and subtracting positive and negative numbers. So if we have 3 minus 9, you would know that this would be a negative number because you will start at positive 3, and you're going to be moving 9 units going to the negative direction, and if you go farther to the negative direction, you'll have a smaller number. So you'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is why the answer is negative 6. Now, knowing your number line and knowing how your answer becomes positive or becomes negative, it all boils down in your visualization of the number line. So let's visualize our answer for number 5, 6, and 7 without really finding the actual answer that we're looking for. This is a test if you are really understanding the concept of the number line. So for number 5, if we're going to guess what our answer would be if we answer negative 22 plus 10, negative 22 means you're going to go to the negative 22 and move 10 units to the positive direction. What do you think is the sign of your answer for problem number 5? And in this case, negative 22 plus 10, our answer would become a negative number, or would stay as a negative number, because positive 10, or the movement to the positive direction, is not going to reach beyond 0. That's why your answer is still going to be negative. And for number 6, 12 minus 15, you start at 12 and you move 15 units going to the negative direction. So your answer here will be negative as well. And for negative 37 plus 2, you start at negative 37 all the way down to the negative value, and you just move 2 units going to the positive. So that means the result of your subtraction or your addition in this case is still going to be negative. So that is how you are going to visualize your number line, and how you would know if you're really understanding the concept of the number line when you're adding and subtracting positive and negative numbers. So here we have negative 10, negative 3, and negative 35 as our answer for these questions. Now, next set of problems, we'll have problems involving 2 negatives or subtraction of negative numbers. So if number 1 is negative 5 minus 3, using what we did a while ago, negative 5 means you will start at negative 5, and you're going to move 3 units to the negative number. So we have 1, 2, 3. So our endpoint is at negative 8, so our answer is at negative 8. So remember, the farther you are to the negative line or to the negative side of the number line, the lesser the value of that particular number. And if your negative number is getting closer and closer and closer to 0, that means your negative number is getting bigger and bigger and bigger. So that is something that you need to think about when you are dealing with a negative number. So this is negative 8. And for the other question, which is negative 5 minus 8, it means we're going to start at negative 5. And we're going to move 8 units to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 8. So we're going to be finding or getting an answer of negative 13. So even though negative 13 is no longer the number line, but since you're already visualizing your negative number in your head, you know that our integers is not limited to just negative 10 and positive 10. And working out problem number 3, again, the answer here will be going overboard our number line. But since you already know the concept of the number line, negative 7, moving 10 units going to that direction will give you negative 17. And for negative 3 minus 9, you are going to start at negative 3. And you're going to move 9 units to that direction. And you will stop at negative 12. So this is how we subtract integers that looks like this. And again, to test if you're understanding the concept of this particular pattern of subtracting integers, let's see if you can figure out the signs of the results in subtracting 5, 6, 7, and 8. And for number 5, we'll have negative 22 minus 10. So negative 22, this is 0. Negative is this part. So negative 22 minus 10 is moving farther away to the negative side. So this is a negative answer. Same with negative 12 minus 5 or minus 15. It's still going to be negative. Negative 37 minus 2, moving to the left, it's still going to be negative. And negative 57 minus 25, negative 57 minus 25 is going to still be a negative value. So knowing the sign or predicting what your sign of the answer would be is enough indicator that you are understanding the concept of the number line. And if we're going to actually solve this problem, negative 22 minus 10, negative 12 minus 15, negative 37 minus 2, and negative 57 minus 25 will be as follows. And notice that all our answers are negative. And if I'm going to ask you among these numbers, which number would be the biggest value or would have the biggest value? And in this case, the number that has the biggest value obviously is not negative 82, but going to be negative 28. So this will be the number with the biggest value because negative 28 is closer to 0. So again, when your number is closer to 0, your value for that particular negative number is becoming bigger. So this is how we work out problems given this particular pattern in your integers. And now, multiplication and division of positive and negative numbers is pretty basic and pretty straightforward because the rule is pretty simple. The rule is, obviously, you should know your multiplication table. However, if you're working with integers, the rule is if you have the same sign, the result of your product or quotient would be positive. And if you have different signs, dividing and multiplying two numbers will be negative. So let's say we have negative 3 minus 5. Negative 3 minus 5, it means that your sign will be positive, and then of course you will be multiplying it using your multiplication table that you should know by now. And 3 or negative 3 times negative 5 is a positive result, and it's going to be 15. And if we're going to be multiplying negative 3 and 5, it may look similar, but the result will be different because now you will apply the rule of multiplying integers, which means your answer for number 2 will be negative, and it's going to be negative 15. And 15 and negative 15 are not equal or not the same because 15 or positive 15 will be on this side of the number line, and negative 15 is on the other side of the number line. That's why in mathematics, the sign of your results is extremely important because it gives you a different value. So if I have negative 25 divided by 5, since multiplication and division have the same rule, I'm going to have a negative result for number 3, and my answer, knowing my multiplication table, is going to be negative 5. Similarly, if I'm going to be dividing negative 88 and negative 8, it will give me a positive result because now I am dividing two numbers with the same sign, and this will turn into positive 11. So this is how we simply multiply and divide positive and negative numbers, and the rule again is pretty simple because you only need to look at the signs of your numbers that you're going to be multiplying and dividing. Same signs is positive, different signs would be negative. Now, knowing your rule in multiplying or dividing integers would help you answer problems like this. Now notice that in this particular example, we have multiple operations that can get a little bit confusing if you're not understanding how the integers work. When you see double operations like 1 and number 2, what you need to do is to perform 2 steps. And the 2 steps would be, first step, simplify your expression, and step 2, use the number line. Alright, so let's apply those 2 steps in answering problem number 1. In problem number 1, notice that we have a positive and a negative symbol in between the two integers. So simplifying them means we're going to be applying the multiplicative rule for integers. And we know that if we have a positive and a negative sign, the sign or the resulting sign would be negative. So simplifying this expression would look like negative 5 minus 3. And now we have a simple integer problem that we can easily subtract using a number line. So now we have negative 5 minus 3, and we'll have negative 8 as our answer. So that is how you evaluate or how you solve integer problem with double or multiple signs in their operation. Doing problem number 2, we have positive 5 minus negative 3. That means we're going to be simplifying the two negatives. And the two negatives is going to turn into positive. So from 5 minus negative 3, or 5 minus minus 3, we'll be able to simplify this expression into 5 plus 3. And 5 plus 3, as we know, we don't even need to use the number line. It's just going to be equal to 8. So seeing 5 minus minus 3 may be a little bit confusing, but if you will simplify your equation, you'll be understanding how simple and basic that math problem is. And that is why you need to know your fundamentals when you're working with a math problem, because knowing your fundamentals and your basic rule will help you understand that simplifying an equation or an expression is a skill when you start working with complex math problems, say 3 plus x equal to 7, or 2 all over x plus 3 is equal to 9, and you're looking for x. That's basically how your brain should think when you answer problems like this. Simplify and then solve. So now that we know those 2 steps, let's apply it with number 3 and number 4. So for number 13, we are going to be simplifying positive and negative. They'll turn into negative. So from 13 plus negative 4, now your equation is simplified into 13 minus 4. And we know that 13 minus 4 is simply positive 9. And if I have 32 minus negative 7, we are going to be simplifying the two negatives. And now we have 32 plus 7, which will give us positive 39. So that is how you deal with problems similar to the 4 expressions or examples that I have shown you. And as a recap, knowing what I have given you in the techniques and strategies on how to add and subtract integers, let's see if you can answer problems number 1 to number 6. So, pausing this video and answering this problem using your number line should give you number 1, 5 plus negative 4 will turn into 5 minus 4. This one is a negative answer. This one is a positive answer. This one will be simplified into negative 7 minus 3. This one is going to be a positive answer, and this one will be simplified into 8 minus 15. And answering this problem using the number line will give us 1, 16, and 2 for the first 3 problems. And for the next set of integers, simplifying and solving it will give you negative 10, positive 9, and negative 7. And that is how we work out problems involving integers. And again, fundamentals in mathematics is extremely important because that is how you will be able to understand the language of math when you go to classes like algebra, calculus, trigonometry, and statistics. And going further, answering problems like this, or this, or this, it all boils down into knowing and understanding integers, because you're not going to be able to understand how to answer problems like this if your fundamental in mathematics is still a little bit shaky. And that is our lesson for today. And if you happen to like this video, please like, share, and subscribe to my channel. Thank you, and see you again next time. Variability. And when we say variability, it's their differences. And if we have a lower variability, it is